Dear students, welcome to CR's digital classes. Today's concept is one tail and two tail test. Tail test we'll call, right? So let us check it out how it goes on. So one tail test and two tail test. Let us check it out. What are the definitions? How it goes on. So one tail test we have here in a statistical hypothesis test. If an alternative hypothesis is denoted by greater than right-tailed or less than left-tailed symbol, then this hypothesis test is referred to as a one-tailed test. So first one-tailed test let us discuss. So one-tailed test, actually this test, two-tailed test, one-tailed test, we get through alternative hypothesis. We get the idea of taking one tail or two tail based on the alternative hypothesis. So based on the question, we'll write alternative hypothesis. There, based on the symbols what we have obtained, we'll decide which tail test it is. So when we'll draw the graph in that, we'll in that curve, we'll check it out, this right tail, left tail, or the two tail test. So that situation they are explaining here. So whenever alternative hypothesis, if you get greater than symbol in that, we'll call it as right tail test. Means we'll get the symbols greater than that, we'll call as right tail. If we get less than, we'll call it as left tail test. So because it is only one side, either on left side we'll plot or either on right side we'll plot. So that we'll call it as one tail test. Only one side it will be, right? So we'll call it as one tail test. So let us check example also how it goes on. H1 mu is greater than mu naught. H1, we know it's a representation of alternative hypothesis, symbol for alternative. So H1 mu greater than mu naught. For suppose if you are checking it out with the population mean, so mu greater than mu naught, we will get a greater than symbol we got. So it refers to the right tail test. Greater than the data will fall into the right side of the curve. So we'll call it as right tail test. Similarly, H1 mu less than mu naught if at all you have. So that refers to left tail test, because whenever we plot the graph, to the left side will get the data over there, or left side will alpha will fall into the left. So we'll call it as left tail test, and in alternative hypothesis we'll get the symbol as less than. So that is your one tail test, either left tail or right tail based on the symbol. So next, these two tests collectively known as single tailed test. So single tail test also we can call, because only single tail will go at a time. So we can also call them together as single tail test. Next, when the alternative hypothesis contains greater than symbol, then the critical region is completely located in the right tail of the distribution. But when the alternative hypothesis contains less than symbol, the critical region is completely located in the left tail of the distribution. Yes, just now we discussed that, right? So greater than symbol we have, if at all we are going to draw the curve entirely to the left side, it will fall our critical region alpha entirely to the left side, it will fall, then we'll call it a left tail test. Or completely if it falls to the right side of the curve, our critical region entirely to the right side, we'll call it as right tail test. So that's what they are specified here. Now through the graph, let us try to learn how this right tail left tail test will go on. So first example, mu greater than mu naught I have considered, that is your right tail. Greater than symbol we have, right tail. So whenever we'll try to plot the graph, we'll shade critical region to the right side. So check it out, this is a critical region. This is not accepting, this is alpha, this is your critical region which will reject. Critical region alpha we have, that falls to the right side. For that only we'll call it as a right tailed test, because right side we are plotting the graph. So check it out, this is shaded part we have, no. So this entire shaded part we have done to the right side. For that only we named it as a right tailed test. So Z alpha is a critical value whatever you will get in the test. So that is your plotting to the right. So we'll call it as a right tail test. Next, leftover region, everything whatever the leftover region we have, we'll call it as acceptance region, that is 1 minus alpha other than alpha part. So 1 minus alpha goes to, we'll call it as acceptance region. So that is an example through graph we have learned. Now let us check it out. One more example to learn about the left tail test. So left tail falls whenever mu is less than mu naught we have. H1 mu is less than mu naught we have. So draw the graph again. Now the critical region falls to the rejection region falls to the left side of the curve. So check it out. This one is your rejection region or critical region we'll call. So this entire shaded part, check it out, it is completely to the left side, right? For that we'll call it as left tail test. So less than symbol whenever we'll get, whenever you'll try to plot the graph, entirely to the left side we'll plot it. So that we'll call it as left tail test. And leftover region, obviously whatever the leftover part we have, we'll call it as acceptance region, and that formula is 1 minus alpha. Other than alpha, 1 minus alpha goes to acceptance region. So this is the example for one tail test, that is your left and right tail test. Now let us check it out for two tailed test. So one tail test, only single you'll get, either right side plotting or left side plotting. So single tail test or one tail test will call the same thing. If you two sides, if we plot the graph, we'll call it as two tail test. How it goes on, let us have a glance now. So two tail test. In a statistical hypothesis test, if an alternative hypothesis is represented by not equal to symbol, so symbol will be not equal to, now previously greater than less than we discussed, right? Now not equal to symbol, if it appears in alternative hypothesis, that goes to two tail test. So then this test is referred to as two tail test because the critical region, which is divided into two parts, is placed in both right tail and left tailed tails of the distribution. So what we discussed just now, in both sides, if you draw the curve, right side, left side, in both sides will be plotting our critical region. For that only we'll call it as two tail test. Two sides we are plotting, right and left. So we'll call it as two tail test. Now let us check it out that also through the graph. So H1 symbolically will represent as not equal to always. So mu is not equal to mu naught, refers to two tail test. Now how it goes on in the graph. So draw a graph. Now plot alpha. Alpha by 2, half to the left, half to the right. So alpha by 2 will get alpha by 2 here, alpha by 2 rejection region or critical region will call. So plot it completely to the left side as well as completely to the right side. So alpha by 2 here this side and here this side. So both sides we have plotted because it is not equal to type, and because we have plotted in the both sides, we'll call it as two tail test. So this is your rejection region plotted on both sides. So Z alpha minus Z alpha, because we know in graph left side will be negative values. So minus Z alpha to the left side, positive values to the right side. So Z alpha to the right side. So this is your graph whenever two tail test will obtain. This is how our graph will be obtained. Leftover region obviously is the acceptance region, that is 1 minus alpha. So this is your two tail test graph. So two sides will plot the critical values. So we'll take the two critical values on the two sides. For that we'll call as two tail test. So this is your tail test. One tail, two tail. One tail, two types we have, right and left. Whenever greater than symbols you will get in alternative hypothesis, we'll call as right tail test. Whenever less than symbols you will get, we'll call it as left tail test. Whenever two sides will plot the critical region, we'll call it as two tail test, because on both sides we are getting our critical values. So this is the concept of a tail test. Hope you have understood this session. See you all in the next session. Thank you.